All right, welcome in, Focus Learners. If you've got an AI exam coming up, or honestly, if you just want a really solid, organized grasp of the subject, you've landed in the absolute right place. Think of this explainer as your ultimate, fully highlighted notebook flip-through. I'm going to be your exam expert today, and we're going to visually map out everything, and I mean everything, you need to know about AI and instructional technology. So grab your mental highlighters because we are breaking this down step by step. Let's get right into it.
Okay, here's our syllabus for today. 1. AI and ML basics. 2. Branches of AI. 3. The Generative AI Revolution. 4. Modalities and uses. 5. Prompt engineering. And 6. Limitations. Let's roll.
Section 1. AI and ML Basics, the Foundations.
So, if you get a short answer question asking you to actually define AI, start right here. At its core, artificial intelligence is just a branch of computer science. The main goal? Building systems that can perform tasks that would normally require human intelligence. We're talking about machines simulating our ability to learn from experience, use logical reasoning, solve complex problems, understand natural language, and make decisions in real, changing environments.
Now put a huge star next to this quote right here because it is absolute gold for an essay intro. NASA defines AI as a system acting in a variable environment without substantial human supervision that improves with data and experience. IBM says something really similar, talking about simulating human learning and autonomous decision-making. The real keywords you want to remember here are autonomous and experience. Basically, the more data the machine gobbles up, the smarter it gets.
But how does it actually get smarter? Well, through machine learning, or ML. ML is basically the science of getting machines to process data and make decisions without us having to explicitly program every single step. Now, you absolutely need to know these 4 training paradigms for your multiple choice questions. First up, supervised learning. Think of a student studying with flashcards, where the answers are right on the back. The system gets labeled data to recognize patterns. Second is unsupervised learning. Here, the data has no labels at all. The machine acts kind of like a toddler sorting blocks, grouping things into clusters just based on what looks similar. Third is semi-supervised. This is where the model connects the dots when you just sprinkle a little bit of unlabeled data into the mix. And finally, reinforcement learning, pure trial and error. The machine gets feedback on its actions, sort of like a player learning to beat a video game by figuring out what scores points and what gets them a game over.
All right, moving on to Section 2, Branches of AI, the AI family tree.
Consider this your ultimate checklist. The 7 main branches of AI include machine learning and its much deeper cousin, deep learning, which, by the way, uses really complex neural networks like CNNs and transformers. Then we've got computer vision for pulling understanding out of images, natural language processing, or NLP, for interpreting human language, expert systems, fuzzy logic, and finally robotics, which is basically integrating AI into physical machines. Let's actually zoom in on 2 of the most frequently tested branches here.
First up is fuzzy logic. If you see this pop up on an exam, remember, it is not about strict true or false, 0 or 1. It's a many-valued logic where truth values can live anywhere between 0 and 1. So, the biggest takeaway here is that it's absolutely perfect for modeling uncertainty. A fantastic real-world example you can use is a medical diagnostic system. You know, symptoms aren't always black and white, right? So the digital doctor has to reason with imprecise, kind of overlapping information.
Next up, expert systems. These are AI programs designed to emulate human specialists. I actually want you to draw a line right down the middle of your page for this comparison. An expert system needs 2 distinct things, a knowledge base and an inference engine. The knowledge base is literally just the raw facts, the textbook, basically. But as we know, a textbook can't make decisions on its own. That is where the inference engine comes in. It's the reasoning mechanism, the brain, that uses logical strategies to actually pull conclusions out of those facts.
Section 3. The Generative AI Revolution.
Okay, this is the hot topic right now. If there's an essay question on your exam, there is a massive chance it's going to be about this. Generative AI, or Gen AI, refers to algorithms that produce completely novel, human-like content. It doesn't just analyze things, it actually creates text, images, audio, video, code, you name it. And these are powered by massive systems called large language models, or LLMs, which are trained on just unbelievably huge datasets. The tools you already hear about all the time, ChatGPT, Google Gemini, Anthropic's Claude, they all fall under this umbrella. For visuals, you've got DALL-E 3 and Midjourney, and for video, OpenAI's Sora. They learn patterns and styles to generate totally creative outputs based entirely on whatever prompts you give them.
And this sets up a totally classic compare and contrast exam question. Discriminative AI versus generative AI. Here's the deal. Discriminative AI categorizes, or predicts. It corrects your grammar, recognizes a face on your phone, or predicts a student's final grade. Generative AI, on the other hand, builds from scratch. It doesn't just correct a sentence, it writes the whole story. It doesn't just recognize a face, it synthesizes a completely new photorealistic image just from a text caption. It can literally write full lesson plans automatically. So, you might be wondering, why is this massive explosion happening right now? Definitely jot down these 4 enabling factors. 1. We finally have massive data sets available to train on. 2. We've seen dramatic advances in computational power, specifically with GPUs. 3. Major algorithmic breakthroughs in deep learning, things like CNNs, GANs, and transformers. And 4. The massive spread of open-source models, which is just hyper-accelerated global research. Those are the 4 exact ingredients that made this revolution happen.
Section 4. Gen AI Modalities and Uses. All right, we're going to do a rapid-fire review of Gen AI modalities to really lock these practical applications into your memory. First up, text-to-text and text-to-image. With text-to-text, you type a prompt, you get text back. Think machine translation, automatic summarization, or just having it write your email replies for you. Text-to-image is where you type a description and the AI generates stunning graphic design visuals, synthesizes character avatars, or even drafts full advertising campaigns just from a simple product brief.
Keeping the pace up, we've got text-to-video and text-to-speech. Text-to-video can automate entire film pre-productions or instantly convert your lesson plans into highly engaging instructional videos. Text-to-speech turns written words into incredibly lifelike audio. We use it all the time with voice assistants like Siri, but it's also totally revolutionizing audiobook narration and providing really crucial accessibility tools for folks with speech or visual impairments. Finally, we have the reverse, image-to-text. This covers optical character recognition, or OCR, which is amazing for digitizing old printed documents. But even more importantly, it generates automated alt text for web accessibility, and it powers scene description services that act as digital eyes for the visually impaired. The real-world impact here is just profound. Now, if you need a really comprehensive case study to write about, look absolutely no further than ChatGPT. Developed by OpenAI, it is pretty much the ultimate generative pre-trained transformer. And modern versions, like GPT-4o, while they aren't just text anymore, they are truly multimodal. That means they seamlessly blend text, image, and audio into incredibly natural multi-turn conversations. It can answer your questions, edit your essay, and generate an image for you, all inside one single chat window. Make sure you highlight those exact terms.
Section 5. Master Prompt Engineering.
Okay, grab your pens because this section isn't just theory for a test. This is a highly practical, real-world skill you can literally use today. Prompt engineering is basically the systematic design of inputs to get the absolute best possible outputs from Gen AI. Here's your foolproof 6-step recipe. 1. Assign a role. Say, act as a pediatrician. 2. Define the task. Exactly what do you want it to do? 3. Give context, like I'm a university professor. 4. Specify the format. Use bullet points. 5. Define the audience, like explain this to a 10-year-old. And 6. Provide examples to guide the style. If you use this exact framework, you're going to get exactly what you need out of practically any model.
Section 6. Limitations and Exam Review. We are bringing our masterclass to a close by looking at the red flags. And listen to me, examiners literally love to test you on these caveats, so circle these terms in red. First up is hallucination, because LLMs are really just predicting statistically likely tokens instead of verifying actual truth. They can and will fabricate information that sounds completely plausible but is entirely false. Second is misinterpretation of subtle linguistic nuances. Third is bias. If an AI's training data overrepresents certain demographics, its output is simply going to reflect those skews. And fourth, technical fragility. These are rapidly evolving tools, they have bugs and epistemic errors, you can never trust them blindly. If you want to end your essays with some really strong modern examples of the current software ecosystem, you'll want to cite these tools. Mention Hagen or Akul for creating avatar-based videos from just a single photo. Mention Notebook LM as an amazing AI research assistant for turning massive documents into visual notes. And for education specifically, definitely cite Magic School and Education Copilot as powerful tools for curriculum planning and generating assessments.
All right, we're going to close our notebooks today with a final, pretty provocative thought. It's really the ultimate question at the intersection of AI and humanity. If AI inherently reflects the biases of its training data, and if it can so effortlessly hallucinate reality, how much of our future decision-making should we actually hand over to the machine? Definitely reflect on that as you prep for your exams and step into this wildly tech-driven world. Thanks so much for studying with me today.